Okay, real quick, I'm going to review how to run an independent samples t-test. What you need to run a test like this is two variables, one of which is going to be dichotomous. Our independent variable is going to be dichotomous. For the analysis I'm going to perform for this video, the independent variable is going to be TA, or teaching assistant. Okay, this refers to which teaching assistant the students had. And our dependent variable for an independent samples t-test has to be interval ratio. Okay. For this analysis, the dependent variable is score on the midterm. Okay, out of 40, score on the midterm. So as you can see here, if I click on the ellipses within the values column for my variable teaching assistant, or TA, there are two values, one for Jay and one for Ben, myself. We each had about half of the students in the class. There are 100 students total, of which Jay has or had 47. Okay, so 100 students wrote the midterm. They all got scores out of 40. Those scores have been entered into SPSS. I have anonymized them, so I've stripped the scores of their corresponding student number and student name. All we have now left are two variables, the score in the midterm and the teaching assistant corresponding to the student who got that score. So we want to run a test. We want to see, and Jay and I actually did this, of course. The question is there a statistically significant difference between the scores that students got who have me as a teaching assistant and the scores that students got who have Jay as a teaching assistant? Now, even if there were found to be a statistically significant difference, it isn't necessarily the case that it's the teaching assistant that is the causal force, but I'll get back to that in a moment. For now, just take note of the fact that the null hypothesis is that there is no difference between the two groups, and the research hypothesis is that there is. Importantly, the super smart among you will notice or take note of the fact that other assumptions are violated. For example, random selection. It isn't the case that people are in tutorials totally randomly. To some extent, students have some say over what tutorial they end up in. And so there may be some connection between what tutorial you choose and other factors that might play a role in the grade you got on the midterm. But again, I'll come back to that in a moment. For now, let's just run the analysis and see if there is a statistically significant difference between the two groups, those who have J and those who have Ben. So I do this, analyze, compare means, independent samples t-test. I click on this, it opens up the dialog box. I already have it preset to the way we want it, but if I was to move it back, there'd be nothing to it. The grouping variable, okay, is our dichotomous variable. So that is teaching assistant. I move that over and I have to define my groups. So the way I have it coded, it's already set up. 1 is J, 2 is Ben, and that's good. So I put 1 in group 1, 2 in group 2. I hit continue. I take the test variable, or the dependent interval ratio variable, and move that over into the test variable box. I then hit OK. If I wanted to, I could click on options and change the confidence interval, but that won't actually change our p-value, as you should hopefully know by now. So it'll just change the meaning of the p-value. The p-value will stay the same, but what we think of it might change. But we can change what we think of it based on just what we think. So I won't go there right now. What I will do is hit OK and then run the test and then interpret the results. Okay. So I hit OK. The output pops up. The first thing I would like you to focus your attention on is the group statistics box. Here we can see that Jay had 47 students, Ben had 53 students. The mean for students who have Jay on the midterm out of 40 was 28.66. For Ben, slightly higher, 30.17. So there is some difference here. That'd be 4%-ish, 5 percentage points out of 100. But and the standard deviations a little bit different as well, but quite close to each other. Same with standard error of the mean. So the question really becomes, is the slight lead that I have over J statistically significant? And then even if it is, the next question will be, is it me and or J that's the cause? But before I go there, let's start interpreting our independent samples test. The first thing you always have to do when you are interpreting the output for an independent samples test is first look at your Levene's test for equality of variances. Okay, this is a sub-hypothesis within your broader hypothesis test. The Levene's test tests the null hypothesis that the variances are equal on your grouping variable. Okay, so it tests the null hypothesis that the variance for J students and the variance for Ben students on the dependent variable score on the midterm are equal. And you interpret it just like you would any other p-value. It's an F distribution it works with, but we don't need to worry about that now. We'll worry about that more when we get to analysis of variance or ANOVA tests next week. For now, just focus on the sig value or the p-value, okay? The null hypothesis is that the variances are equal along our grouping variable, and the p-value or sig value is 0.611. So if our alpha level was 0.05, if we wanted to be 95% certain before we rejected the null hypothesis, we could not even come close to rejecting the null hypothesis, in this case, that the variances are indeed equal. So we will proceed to interpret the rest of our results, our t-statistic and our p-value for our actual test, assuming that the variances are equal. Had this p-value or sig value been less than 0.05, at an alpha level of 0.05, we would have rejected the null hypothesis and then proceeded reading the bottom line of the output, equal variances not assumed. But it's 0.611, which is quite a bit bigger than 0.05, so we are going to maintain that the variances are equal, and we're going to read across accordingly. The test statistic is negative 1.667, 98 degrees of freedom, which is the number of cases in the sample minus the minus the number of values within the grouping variable, dichotomous variable minus 2, 100 minus 2 equals 98. Good. The p-value for this test, the p-value for our more important, our wider hypothesis test now. Remember, we're testing the null hypothesis that there is no difference between the midterm grades of J students and the midterm grades of Ben students. Well, the sig or p-value for that hypothesis test is 0.099. Okay, so at an alpha level of 0.05, if we wanted to be 95% certain before rejecting the null hypothesis that there is no difference between the average midterm score for J students and Ben students, then we could not, with a p-value of 0.099, we could not reject that null hypothesis. Okay? If we had chosen a p-value of 0.1, if we only wanted to be 90% certain before we were willing to reject the null hypothesis, then, in this case, we would be able to reject the null hypothesis. It would appear that Ben students had a slightly higher average, but in the social sciences, an alpha level of 0.05 is accepted, so strictly speaking, there is no statistically significant difference between the two groups. Now, importantly, before I conclude, even if our p-value, let's say that J students got like an average of 37. No, that wouldn't work. Okay, let's say that Ben students got an average of 37. I like that better. Yeah, Ben students had an average of 37, and J students kept their same average, so 28.66. Even if that was the case, we would certainly be able to say there was a statistically significant difference between the two groups, J students and Ben students, but we still wouldn't be in a position to say that the teaching assistant was the causal factor behind that difference. For example, as you are all aware, Jay has all the tutorials each week before the lecture. Okay, I have all the tutorials after the lecture. Things tend to make a little more sense each week after the lecture, so it's quite likely, very arguable, that that plays some role, if not a larger role than the difference between Jay and I in determining the average score on the midterms. But there's no need to further dwell on such causes. For now, just know that we had our grouping variable, our dichotomous independent. We ran our test. We looked at our group descriptive statistics. We interpreted our Levine's test. We read over accordingly. We interpreted our results for our real hypothesis test. We failed to reject, and now we can set about writing up our findings. Have a nice day.